Hi friends, welcome to 5th lecture on Class 10 Science, Chapter 13, Magnetic Effects of Electric Current. Till now, we have learned that a current carrying conductor can produce a magnetic field. Now, is the reverse possible? Can a magnetic field produce a current? Let's find out in this video. So, this was discovered by Michael Faraday. In 1831, he discovered that a moving magnet can be used to generate current. And this process is called electromagnetic induction. Electromagnetic induction is a process in which the changing magnetic field induces current in a conductor. We can induce current by two ways. First, moving a coil in the magnetic field, and second, by changing the magnetic field around the coil. So either by moving a coil in a magnetic field or by changing the magnetic field itself, we can induce current. Now let's conduct an experiment to verify electromagnetic induction. So this is known as Faraday's experiment. In this experiment, we take a coil of wire and connect it to a galvanometer. Now what is this galvanometer? So galvanometer is an instrument that can detect presence of current in a circuit. Now, how does this galvanometer detect presence of current? So here I have a model galvanometer. The pointer remains at 0 when no current is passing through it. So here you can see that the pointer is remaining at 0. So this means that currently no current is passing through the circuit. Now the pointer deflects either to the left or to the right of the 0 mark depending upon the direction of current. So whenever current will be passed through the circuit, then galvanometer pointer will get deflected either in the left direction or the right direction, like this. So now let's come back to Faraday's experiment. So we had taken a coil of wire and connected it to a galvanometer. Now bring a bar magnet towards the coil with its north pole facing the coil. So the north pole of the magnet should face the coil and we will steadily bring it towards the coil. Now let's see few observations. When magnet moves towards the coil, then galvanometer needle deflects towards the right. Thus this reflects that current is induced. Second, when the magnet is at rest, then deflection drops to 0. And this means that current is induced only till the magnet is in motion, and as soon as it comes in rest, then no current is produced. Third, when a magnet moves away from the coil, then galvanometer needle deflects towards left. So again some current is induced. Now in this experiment, when the magnet is brought towards the coil with its south pole facing the coil, then direction of deflection of galvanometer is reversed. Hence, direction of magnetic field and direction of induced current are interdependent. Now, can we find the direction of induced current? Yes, this can be found by using a very special rule called Fleming's right hand rule. So, to apply Fleming's right hand rule, stretch your thumb, forefinger and middle finger of your right hand such that they are mutually perpendicular to each other. So here I have taken my forefinger, I have taken my thumb, forefinger and center finger such that they are mutually perpendicular to each other. Now, if the forefinger indicates the direction of magnetic field and the thumb shows the direction of motion of conductor, then the middle finger will show the direction of induced current. So to find the direction of induced current, let's take an example. So consider that magnetic field is in this direction. So we will keep our forefinger like this. And our motion of the conductor is in upward direction. So we will keep our thumb in the upward direction. Then the middle finger will show the direction of induced current. So in this case, induced current will be like this, in this direction. Now an important question comes, how to remember this rule, that which finger will show which thing. So to remember Fleming's right hand rule, we have a very easy trick. So this is my first finger or forefinger. So F for first and F for field. So the first finger shows magnetic field. Similarly, this is my center finger. So C for center and C for current. And this is my thumb. So T for thumb, and in motion T comes. So therefore thumb shows motion of conductor. Now let's see a practical usage of electromagnetic induction. So the principle of electromagnetic induction is used to produce large currents for use in home and industry by electric generators. So in an electric generator, mechanical energy is used to rotate a conductor in a magnetic field to produce electricity. So electrical generators convert mechanical energy into electrical energy. And you can see that electric generators are just the opposite of electric motor. In electric motor, electrical energy was being converted into mechanical energy, while in electrical generator, the mechanical energy is converted into electric energy. Now, there are two types of generators, AC generators and DC generators. AC generators generate AC or alternating current, while DC generators generate DC or direct current. AC current reverses its direction periodically, while DC current always flows in one direction. It doesn't change its direction. Most power stations in India produce AC. And in India, AC changes its direction after every 1000 seconds. This means that its frequency is 50 Hz. First, let's discuss AC generator. Construction. So, AC generator consists of the following components. First, armature. So, it is a rotating rectangular coil ABCD. Second, magnetic field. So, the coil is placed between two poles of permanent magnet. Third, slip rings. So, the ends of coils are connected to two rings R1 and R2. So, in electric motor, we saw split rings, which were half rings, but in AC generator we have slip rings, which are full rings, as you can see in the diagram. And the fourth component is brushes. So two conducting stationary brushes B1 and B2 are in contact with the rings R1 and R2 respectively. So B1 is in contact with R1 while B2 is in contact with R2 ring. Fifth, axle. So the rings R1 and R2 are internally attached to the axle. This axle is mechanically rotated from outside to rotate the coil inside the magnetic field. And the sixth component is galvanometer. So the outer ends of brushes are connected to a galvanometer to show the flow of current in the circuit. So galvanometer is used to detect whether current is produced or not. Now, let's understand the working of AC generator. So, when the axle attached to the two rings is rotated, the armature coil also rotates. As the coil rotates, a magnetic field changes continuously and hence induced current is produced. We have already studied this process of electromagnetic induction. Now, suppose the coil is rotating clockwise. So, as you know that the coil has two arms, AB arm and CD arm. So if the coil is rotating clockwise, then AB arm will move upward and the CD arm will move downward. So it will be like this. And if AB arm moves upwards, then applying Fleming's right hand rule, we get that direction of motion is like this, magnetic field is like this, so induced current will be like this. So the current will be inward. So the current will move from A to B in AB arm. While in CD arm, it moves downwards. Hence, current will move outwards. So, it will be like this. The motion is down. The magnetic field is in this direction. So, the current will be outwards. That is from C to D. And we have got all this by applying Fleming's right hand rule. Therefore, the path of current will be, if in the inside of the coil, it will be from A to B to C to D. And then it will move to brush B2 and then to brush B1. So this external circuit, the path of current will be from brush B2 to brush B1. After half rotation, the position of arm CD and AB reverses. So arm CD moves upwards and the current moves inwards, that is from D to C, while arm AB moves downwards and current in it moves outwards, that is from B to A. So now the direction of current will also get reversed. Now the path of current would be from D to C to B to A. And in external circuit, it will also get reversed. So it will be from brush B1 to brush B2. Earlier it was from B2 to B1. Now it will be from B1 to B2. Thus, after every half rotation, the polarity of current in respective arms changes. Such current which changes its direction after every equal interval is called AC current. So this was all about AC generator, and now let's discuss DC generator. To get direct current, a split ring type commutator must be used. This reverses the direction of current in a circuit so that unidirectional current is produced. In this arrangement, one brush is at all times in contact with the arm which is moving upwards, while the other brush is in contact with the arm moving downwards. And you can see this in the diagram. We have already seen the working of split ring type commutator in the DC motor video, and it remains same here. Now, can you tell me which is better, AC or DC? So the advantage of alternating current over direct current is that electric power can be transmitted over long distances without much loss of energy by using alternating current. This was all for today. In the next video, we shall discuss domestic electric circuits. So stay tuned.